Hey folks, so welcome back to numeracy in physics, and this is going to be the sort of second or third lesson on numeracy before we move on to the actual physics, okay? So we're going to look at something called prefixes. This is really important because we use prefixes all the time in physics. And one of the common problems I find is that people can't remember what the prefixes are, and then they struggle to actually do the physics, okay? So really make sure you understand this lesson, and if you don't, let me know or go through the slides again until you do. Okay, so here are the prefixes that we use, and the prefixes have a name. So the names are given down the side here. Okay, and then they have a symbol because we're lazy as physicists. We don't always write down the full name. And then we have the factor, so we know what the prefix actually stands for. Okay, so one of the most common one which you probably use quite a lot is kilo, as in kilograms, which is represented by a K. So now you know why the unit for kilograms or kilograms is kg, and you multiply by 1,000. Okay, and again, you know that to get kilograms into grams, you multiply by 1,000. Okay, another one that you're probably familiar with, but you might not realize it, is centi, because centi, if I write it like this, you probably recognize it as centimeters. And remember, to get from centimeters to meters, you divide by 100, which is really what this is saying here. If you're multiplying by 10 to the minus 2, it's the same as dividing by 100. Okay, now what I would like to do is for you to try and remember all of these prefixes, their symbols, and what the factor is if you want to replace them. Okay, it's a straight recall. There's really nothing to understand. You just have to remember it. So, why do we use prefixes? Well, they're another way for us to write big numbers in a really quick and compact way. The way we use them is that we just replace the scientific factor, the times 10 to the bit, with the prefix symbol. Okay, once we do that, we can also simplify the answer a little bit further, which I'm going to show you in the next slide. So how do we use it? So here's an example, folks. Well, here we've got 1 kilometer. So if we want to get rid of the prefix k, we just write down times 10 to the 3, because that's what the K represents, times 10 to 3. And it's as easy as that. Okay. 1 megajoules. Again, if we get rid of the M, we just write down times 10 to the 6. And that's all it is. Okay. Dead easy. Nothing difficult at all. Okay. 200 nanometers, a wee bit trickier now because we've got this 200. Now the nano stands for times 10 to negative 9. So you could just write 200 times 10 to negative 9. Perfectly happy with that. I think that's a fine answer to put down. If you want to simplify it, remember you've got these extra 2 zeros here, which means you're going to reduce this number from 9 to 7. Because if you put this in the calculator, it would actually simplify it to 2.0 times 10 to the 7 meters. Don't worry if you can't get this bit here. As long as you can get this bit, that's the main thing. Okay. And again, another example, 130 megawatts. The mega stands for times 10 to the 6. But because I'm going to shift my decimal place 2 places, that should actually be an 8 and not a 7. So it becomes times 10 to the 8 watts. But if you just write this one here, I'm perfectly happy to accept that as an answer. Okay, 3.5 kilograms, still the same rules. We're just replacing the K for 10 to the 3, and that just gives you 3.5 times 10 to the 3 grams. And that's it, folks. That's how easy it is, basically. Now, here are the most common ones that we're going to use, and I want you to really make an effort to remember these, okay? So 1 kilometer is the same as 1,000 meters. So kilo or kilo, depending on how you want to pronounce it, you multiply by 1,000. Okay, dead easy. 100 centimeters is the same as 1 meters. So centi means divide by 100. Okay, one way I remember that is there are always more centimeters than there will be meters because you're dividing. Okay, I'll say that again. There are always going to be more centimeters than meters because you're always dividing the centimeters to give you the meter. Okay, 10 millimeters, this is one that I've not talked about yet, but it's the same as 0.01 meter. How did I get that? I divided by 1,000. And the way I remember this, again, number one, is that there are more millimeters than there are meters. Secondly, milli actually stands for 1,000. If you think about a millennium, that's 1,000 years. So milli, 1,000, and because there's more millimeters than meters, you divide by 1,000. So those are the three most important ones I want you to try and remember. Okay, it's very easy to get confused because people get mixed up whether it's a times or a divide. So get it clear in your head, folks. Practice it with the questions that I'm going to give you as your assignment. So finally, just take you through those again. 20 kilometers. You can try these yourselves first and then check the answers. That's what I'd be getting to do in class. I'm just going to talk you through them just now. Okay. 20 kilometers is the same as 20 times 1,000. So it's 20,000 meters. 3.5 kilometers, same as 3.5 times 1,000. So 3,500 meters. 300 centimeters in meters. You divide by 100, which becomes 3 meters. 593 centimeters, you're dividing by 100 again, so it becomes 5.93 meters. 4 millimeters in meters, you're dividing by 1,000, so then it becomes 0.004 meters. 748 millimeters, you're dividing by 1,000, so it becomes 0.748 meters. Now, as always, you are allowed to use a calculator. Don't try and do them in your head. And that's it, folks. Nice and straightforward. Things will get a wee bit more challenging later on, so don't worry if you find this easy. That is actually really good. If you're not, this is your chance to really get to grips with it. Okay, folks? And I'll speak to you again next week.